On a calm day, a skyscraper looks perfectly still, solid, unshakable. But when strong winds hit, that solid building actually moves, sometimes by several feet at the very top. So why doesn't it snap? Why doesn't it tip over? Let's break it down. Skyscrapers aren't designed to resist movement completely. They're designed to move safely. Wind isn't just a steady push. It flows around a building. It speeds up. It slows down. It creates pressure differences between one side and the other. And as it wraps around the structure, it forms spinning air currents called vortices that can pull and push rhythmically. That means a tall building isn't dealing with one simple force. It's dealing with constantly changing pressure from multiple directions. If a building were completely rigid, that stress would concentrate in weak points. Over time, that's what causes cracks or structural failure. So engineers do something smarter. They allow the building to sway. Think about a palm tree in a storm. It bends with the wind instead of resisting it. That flexibility keeps it alive. Modern towers like Burj Khalifa are built with this principle in mind. The structure can flex slightly without damage. At the highest floors, the movement can be measurable, but it's controlled, predictable, safe. What this really means is flexibility prevents catastrophe. Inside every skyscraper is a massive reinforced core. This core holds elevators and stairwells, but structurally it acts like the spine of the building. Around it, a network of steel beams and concrete columns distributes wind forces across the entire frame. Instead of the wind hitting one weak spot, the force spreads out. The shape of the building matters too. A flat rectangular tower catches wind more aggressively. That's why many modern skyscrapers taper, curve, or twist as they rise. Look at Shanghai Tower. It spirals upward. That twist isn't just aesthetic. It disrupts wind vortices, reducing the force that builds up along the sides. Less vortex formation means less sway. And then there's one of the most fascinating solutions ever installed in a skyscraper, a tuned mass damper. Some buildings contain a gigantic suspended weight near the top. When wind pushes the building one way, this heavy mass swings slightly in the opposite direction, counteracting the motion. Inside Taipei 101, there's a massive golden sphere weighing hundreds of tons. When the tower sways, the sphere shifts to reduce that movement. It's basically a shock absorber for a building hundreds of meters tall. But survival doesn't just depend on what's above ground. Skyscrapers are anchored deep into the earth with enormous foundations. Concrete piles extend down into stable soil or bedrock. So when wind tries to tip the building, the base resists that rotation. Before any of this is built, engineers test scale models in wind tunnels. They simulate decades of extreme storms. They measure pressure changes, vortex patterns, and structural response. By the time the real building rises, it has already survived more storms and testing than most cities will see in a lifetime. And here's something most people don't realize. Engineers rarely design skyscrapers around the fear of wind collapse. That threshold is incredibly high. They design around human comfort. If the sway is too noticeable, people feel motion sickness. Offices become uncomfortable. So much of the technology inside these buildings exists not because the tower would fail, but because humans don't like feeling like they're on a boat while answering emails. So the next time you look up at a skyscraper, remember this. It's not rigid. It's not fighting the wind. It's moving with it. Carefully calculated, precisely balanced, quietly swaying in ways you'll probably never notice. If you enjoy understanding how the world around you really works, like this video and subscribe to the channel. There's a lot more hiding in plain sight. Thanks for watching.